here as a finalist for the Pearl Harbor Memorial Bridge, which is it's the first extradose bridge that has been designed and built in the United States. This bridge is located in the city of New Haven in Connecticut, and it's part of the I-95 corridor. This project had a lot of public involvement because it was going to be a signature bridge for the state of Connecticut. It was going to be a memorial bridge. This bridge honors the lives lost and the survivors of the Pearl Harbor attack. So it had to be, in the sense, a monument. The piers and the towers had an oval shape. And when you see them, they mimic smokestacks of ships as they may be sitting in a harbor. And when you drive, there's lettering commemorating the date of the Pearl Harbor attack. An extradose bridge, I've put it this way, it's like the child between a cable stay bridge and a conventional post-tension box girder bridge. And the reason why it's a child because it has the look of a cable stay bridge, but it behaves more like a post-tension concrete girder bridge. The stays are actually shallower than the cable stay in an extradose bridge. So there's no, it doesn't really provide vertical stiffness. It provides more of a post-tension into the system. And that's why the towers can be shorter, and that's one of the reasons for the site that the towers have to be short. Another feature of the extradose bridge is that since the stay cables are shallower, they don't have the same fatigue demands that a cable stay bridge has. So when you design a cable stay bridge, fatigue is very important, and so that limits the allowable stress that you can take those steel strands to. In an extradose bridge, the fatigue is a lot less, so you can take it at design, you can go a little bit higher in the design, in the limits of the stress range. It was very important that the existing bridge remained operational during the construction of the new bridge. So in order to do that, the foundation of the new bridge had to be away from the existing foundation. So that set the length of the span. Another constraint was that this bridge is located within 2 miles of an airport, so the Federal Aviation Administration had some requirements for the towers, and therefore that's why the extradose type of bridge was a perfect fit for this location. And another one of the constraints was that the Coast Guard had certain height limitations underneath the bridge, so we couldn't use a type of typical box girder or a steel box girder because usually those are deeper. We used 2 Bentley products actually in this project. Number one, we used Bentley's MicroStation, which is all drawings, all CAD produced drawings were done in MicroStation. That was a requirement by the Connecticut DOT. The second program that was used in the design was Iron Bridge, and that was our choice. As designers, we get to select, and that was the tool that we had at the time, the best tool that we had at the time. There's different costs: the cost of the concrete, the cost of the cable stays, the cost of the post-tensioning. So you have to find the right balance between the stay cables, the post-tensioning, and the cross section. And programs like Iron Bridge help you get the best possible solution within the constraints of the codes. Now we call something 4-dimensional because time is part of the design process. In concrete, there's something called creep and shrinkage, and that happens with time. So as you model this bridge, you have to include the effect of time in the design. So programs like Iron Bridge help you include the effect of time in the design. Not only the effect of time, but the effect of the erection, how you're going to actually build it. In the model, you actually build it as it's going to be built in reality. So it's a really mimics the reality. And based on that model, you get stresses, you get forces, and that's how you do the design.